Welcome to Wonders of the Universe. In this episode, we look at asteroids, the wreckage of creation. In the 550 million kilometers, or 340 million miles, of space between the orbits of Mars and Jupiter lies the asteroid belt. This is where vast mass of rubble circles the Sun in a diffuse and chaotic band. More worlds than we see today condensed out of the solar system's accretion disk, but at least a few of them developed orbits around the Sun that were too elliptical for safety. At some point in the distant past, their paths intersected and they smashed together, creating a swarm of rubble. Each chunk is known as an asteroid. Some asteroids may be the remains of an ancient planetesimal that was unlucky enough to stray too close to Jupiter. Tidal forces from the mighty gas giant tore the smaller worlds apart. The Earth has been smashed into by rogue asteroids many times before. It is bound to happen again sometime in the future. Meteorites are stray asteroids that collide with the Earth, survive their fiery descent, and reach the ground intact. Some meteorites are made of iron, or a mix of stone and iron. Finally, the most common kind of meteorites are stony, very rich in silicate materials, with only small flecks of metal. These are the wreckage from the outermost crusts of planetesimals. Ceres, the largest asteroid, gained sufficient mass and gravity to pull itself into a spherical shape, classifying it as a dwarf planet. Ceres is 960 kilometers or 596 miles across. It orbits the Sun once every 4.6 years. Its terrain, viewed here by the Hubble Space Telescope, shows distinct variations in brightness. The Near-Earth Asteroid Rendezvous probe, NEAR, achieved orbit around asteroid 433 Eros in February 2000. It spent the next 13 months studying the drifting rock. Its weak gravity field was just sufficient to hold the visiting probe in a slow orbit. Eros circles the Sun once every 1.76 years. The most distinctive feature on Eros is a saddle-shaped hollow called Himeros. It is almost certainly an old impact crater. At the bottom right of this image, the small dark specks are rocks and boulders, each larger than a house. The soft undulating terrain is surprisingly suggestive of erosion, perhaps the effect of countless micrometeorite impacts wearing away at Eros over great spans of time. At the end of its mission, the NEAR spacecraft was nudged towards Eros for a deliberate, though very gentle, crash landing. Here we have a montage of major asteroids and comets visited by robotic spacecraft from the 1980s onwards. It does not include Mars's moons, Phobos and Deimos, which are not yet proven to be asteroids. 5 comets and 10 asteroids are featured. Most of these targets were visited only briefly in flyby missions. Only Eros and Itokawa are orbited by their visiting probes, so that they could be photographed and mapped completely. At 560 kilometers, 348 miles across, Vesta, the third largest asteroid, should have been large enough to pull itself into a spherical shape by virtue of its mass and gravity. This Hubble telescope image shows that something must have prevented that from happening. This asteroid is a fairly sizable 66 kilometers, 41 miles in diameter, but it is not as dense as might be expected from such a hefty lump of rock. Its gravity field is only as strong as the effect that a similar volume of water would exert. It may be peppered on the inside with cavities like a sponge. This small lump of rock is an S-type asteroid, rich in silicate materials and metals. In the future, asteroids such as Gaspra may make tempting targets for commercial exploitation. This montage shows a selection of images of asteroid 433 Eros, acquired by the NEA spacecraft over 3 weeks in early 2000. As the spacecraft closed in on its target, the asteroid's natural colour is a subtle butterscotch hue. In June 2000, NEA trained its camera on Eros's largest crater. The darker hues represent rock and regolith, loose dust and rubble that has been altered chemically by long exposure to solar radiation. The lighter patches show areas apparently less affected. The next 3 views of Eros from the orbiting NEA spacecraft map the asteroid's varying gravitational pull as different colours overlapped on 3D scans of the asteroid created from laser rangefinder data. The asteroid's shape, density and spin combine to create a bizarre pattern of gravitational influences. For example, a ball dropped onto one of the red areas would try to roll uphill, then across the nearest green area into the nearest blue area. A tremendous view of Lutetia, sidelit by the sun, gives a menacing impression of this huge mass of rock. In July 2010, the European probe Rosetta made its closest approach to the asteroid 21 Lutetia, a primitive survivor from the violent birth of the solar system some 4.5 billion years ago. Detail of a crater-like feature on Lutetia shows that boulders have participated in a landslide, tumbling down the sides of the depression. The hollow was probably gauged by an impact, but its sides have become softer and more rounded than might have expected. When the Galileo probe flew past the 54-kilometre, 33-mile long stony asteroid 243 Ida in 1993, it discovered that the asteroid has a small moon of its own, Dactyl, roughly 1.4 kilometres, 0.85 miles in diameter. In February 2010, the Hubble Space Telescope observed a mysterious X-shaped debris pattern and trailing streams of dust, suggesting a head-on collision between 2 asteroids. Astronomers have long believed that the asteroid belt is being gradually ground down through collisions, but such a smash has never been seen before. The primary object was thought to be a rare example of a comet travelling near the asteroid belt. Later analysis told a more violent story. In September 2005, Japan's deep space probe Hayabusa arrived at asteroid Itokawa, 300 million kilometers, or 186 million miles away from the Earth. In November of that year, it successfully landed and collected small amounts of material for return to Earth. A detail of the touchdown zone and its location on the asteroid's flank is shown here. The shadow of the Hayabusa probe is evident as it closes in for touchdown. At the end of its visit, Hayabusa set off once again into deep space for the long journey home. In June 2010, the probe's re-entry capsule came down in outback terrain at Woomera in Australia, and it was recovered. A few tiny grains of Itakoa were inside the sample canister. And that concludes our look at asteroids. I do hope you enjoyed this, and if you did, make sure to subscribe because our next episode is going to be on the gas giants. Look forward to seeing you then. Peace, everybody.